Okay, we're on to the last one now. Show that xy equals x plus n times y minus m. Okay, show that this expression x times y is the same value as x plus n times y minus m.
Well, the reason they're the same is because x times y is the area of our old rectangle.
Okay.
And this is the area of the new one, because you have x plus n here, y minus m here.
All right.
So that's why they're the same.
Okay, but how do you know the area of those two rectangles is the same?
Because we used the same pieces. We didn't add anything in.
Okay, so we used all the same pieces to build those rectangles. Okay, now I want to show you something kind of interesting. I'm sorry, I'm going to have to turn the paper. When we multiply this out, we get xy equals xy minus xm minus ny, or plus ny.
Yeah.
And then minus nm. Did I get that right?
Yeah, I think so.
Okay. So we have, let's see if I can get this in on the top. Ooh, not quite. Okay. Where is xy? So we're going to say this rectangle here, that's xy, right?
Yeah.
And this rectangle here is x plus n times y minus n, but that's this multiplied out, right?
Well, yeah, so it must...
So where's the xy in this expression? Where's that area that is represented by x times y?
Well, that's the area of the old rectangle.
Okay.
And then minus x times m.
What is x times m?
It's this little rectangle.
Okay, so what little rectangle are we subtracting away that's x times m?
I think it's this top rectangle.
Okay, so that minus xm represents getting rid of this rectangle. Okay, so now we're left with just these two parts. So that's obviously not enough, right?
Yeah.
Okay, so we have to put on something, n times y. What would that be?
Well, it's n, it's y high.
Okay, so where is that rectangle? It's n wide and y high.
Well, this is almost it. This is n wide and y minus m long.
Okay, so n wide and y high would be what rectangle? Draw it in.
N wide and y high would be that.
Okay. So we started with this rectangle. We subtracted away this rectangle here, this one.
Yeah.
Now we don't quite have our rectangle yet that we're looking for, this sideways one. We got to put in ny, but what's the problem?
There's this bit sticking out.
How big is that bit?
It's n wide and m high, so we have to take that away.
Take that away, and what are we left with?
xy. We're left with the exact same rectangle.
Well, no, it's not. Definitely not the exact same rectangle.
We're left with a different rectangle that has the same area.
Right. So we see that our original rectangle xy can be transformed through this process, which is x plus n times y minus n, into the new rectangle. So you can see it both algebraically and geometrically. That's pretty cool.
Yep.
It's an interesting project. What did you think of that project?
It was fun.
Yeah? What was the hardest part for you?
I think it was just realizing that there was not the side length of AP, but actually on AP itself.
Okay, interesting. Interesting. All right, well, good job. That was good work. That was good geometry work this morning. All right, good job, Ben.